Hello everyone. Today we are going to discuss gas refrigeration cycle. Last session, if you have seen, you must have learned how a Carnot cycle is implemented to produce refrigeration. And I hope all of you have completed the assessment also. Now let us discuss about the refrigeration in which the working medium is a gas. In the Carnot cycle we have seen there are phase changes happening between the processes. Among the various processes, phase change is happening. But when we are using a gas as the refrigerant or the working medium, throughout all the four processes, it will remain as gas. So the gas refrigeration cycle used in refrigeration, it is known as bell-coleman cycle, also known as Joule cycle or reversed Brayton cycle. You must have heard about Brayton cycle, right? It is a power cycle used in gas turbine power plants. The application of that is in aircrafts especially. Okay. So in gas turbine power plants, Brayton cycle is used for power generation. You must have heard about the terms like regeneration, the intercooler, so much terms must have studied in previous semesters. Now when that cycle, Brayton cycle is reversed, just like the Carnot cycle, since all the four processes are reversible in Brayton cycle also, all the four processes could be executed in the reverse direction, and that is known as reversed Carnot Brayton cycle, otherwise Joule cycle or bell-coleman cycle. Okay. Now the difference of this cycle from the Carnot cycle is the isothermal process, that is heat rejection and heat addition were happening in isothermal processes. These two processes are replaced by isobaric process, that is constant pressure, constant temperature, heat addition and rejection are replaced by constant pressure, heat addition and rejection. You can see here there are four components similar to the Carnot cycle. Just have replaced the terms evaporator and condenser, simply we will write heat exchanger. Okay. So there are compressor, turbine, heat exchanger as well as heat exchanger. Again another heat exchanger. Okay. So heat will be absorbed at the amount of QL at a lower temperature, and it will be rejected at the amount of QH in the another heat exchanger. So 1 to 2 is the compression isentropic. On a pressure volume plane, you can see this is a representation of an isentropic process. 1 to 2 is isentropic compression in the compressor. 2 to 3 is performed at the constant pressure, higher pressure, P2 equal to P3, pH we can say, this is PL, okay, P1 equal to P4. Again, there will be an expansion 3 to 4 isentropically in the turbine, and finally 4 to 1 again heat will be absorbed from the space to be cooled isobarically at constant pressure. Okay. So these are the four processes. Only difference is the two isothermal processes are replaced by isobaric processes in a bell-coleman cycle or reversed Brayton cycle. This is equivalent temperature entropy diagram. Temperature entropy diagram, you can see here TS diagram 1, 2, 3, 4. It is executed in the counterclockwise manner, isentropic, isobaric, isentropic, and again isobaric. You must have noted this 1 and 3 are on a same horizontal straight line. In the ideal case, the COP of this refrigeration, you know that is the desired effect by work input, right? The desired effect is QL, which is given by T1 minus TL from the cycle, and the work input is, so there are work input to be given to the compressor and some work output we will get from the turbine. So combining these two, the net work input T2 minus T1. What is T2 minus T1? That is the compressor work input. What we are giving minus what we are obtaining from the turbine, that is T3 minus T4. So minus of T3 minus T4, that will become minus T3 plus T4. Okay, that is the network of the turbine and compressor. That is written in the denominator. That is the coefficient of performance of this refrigeration system. So this is specifically applied in aircraft refrigeration systems. Bell-Coleman cycle is implemented in aircraft refrigeration systems where air is used as the refrigerant. So any questions or doubts, can use the comment section below. Thank you for watching. Have a good day.